Hello everyone, welcome to the second part of the linear regression algorithm. In the first video, we have studied till here and we saw that our aim is to minimize this cost function. Basically, we have to determine that value of theta 0 and theta 1 for which the value of the cost function is minimum. Now, we will try to find out that line today. Let us take different value of theta naught and theta 1. So, first of all, we will take our first case. Let theta naught equal to 0 and theta 1 equal to 1. So, in that case, how will our line look like? H theta of x, that will be nothing but 0 plus 1 times x. This is equal to x. So, this is our line h theta of x equal to x. And suppose we have our data set. That means the value of x and correct value of y given as 1, 1, 2, 2, 3, 3. These are our data set. Now, if we try to find out now what is the value of j theta naught and theta 1, let us see that. It will be 1 over 2 times m is the number of data points. So, we have 3 data points, so we'll get m as 3. And then we have summation h theta of xi. Sorry, this is h theta of xi minus yi square. So here these are our yi's value. This is y1, y2, y3. Now what is the value of h theta of xi? It will be xi only, correct? So if I talk about what is h theta of x1, so that is nothing but x1, which you can see here. This is x1, y1 and x1, x2 and x3. So h theta of x1 will be x1, which is 1. Then we have h theta of x2 is 2, h theta of x3 as 3. So these are our predicted output and 1, 2, 3, y1, y2, y3 is our actual output. So j 0, 1, because we have taken theta naught as 0 and theta 1 as 1. It will be 1 over 2 multiplied with 3 is 6. And here h theta of x1 minus y1 if we do, we will get 1 minus 1 square. Then h theta of x2 is 2, y2 is 2 square. Similarly, h theta of x3 is 3 and y3 is also 3 square. This is nothing but 1 over 6 times. This is going to be 0. So, in this case, we are getting the value of the cost function as 0, correct? How what we can do? Let us take the second case and now we will take theta 1, that means the slope value as 0.5. So, in that case, what will be h theta of x1? First, let us take h theta of x. It will be theta 0, which is 0 already, and theta 1 is 0.5x. So, h theta of x1 means what? H theta of 1, which is nothing but 0.5 multiplied with 1 comes out to 0.5. And corresponding y1 is 1. So, these are our y1, y2, y3 values. Now, h theta of x2 will be nothing but 0.5 times x2. So, 0.5 times x2. x2 is what? It is 2. So, we get h theta of x2 as 1. Similarly, h theta of x3, if we see, this is 0.5 times x3 and x3 is given to be 3. So, 0.5 times 3 comes out to be 1.5. Correct? So, again we will find out j 0, 0.5. So, this will be 1 over 2 times 3, which is 6. And then we have summation. H theta of x1, we can see this is 0.5. So, 0.5 minus y1 square plus h theta of x2 is 1 and y2 value is 2. This is not y square. mind this notation for now. That is 2 years, so 2 square, then y3. S theta of x3 is 1.5 and y3 is 3 square. If we try to solve this and get the value of j0, 1.5, j0 and 0.5, we are going to get the approximate value as 0.58, correct? Let us take one more case. What if we take the value of theta 0 now or theta 1 as 0? So in that case, we have h theta of x as theta 0 is already 0. Theta 1 will be as 0 as well. So we are going to get theta x, h theta of x as 0 only. Correct? That means h theta of x1 is 0, h theta of x2 is 0, corresponding y1 is 1. The given data set are talking about this was 2, and h theta of x3 is 0 as well, and y3 is 3, which is given. In that case, j0 comma 0, it will be 1 over 2 times 3. Subtract these two. So we have 0 minus 1 square, 0 minus 2 square, plus 0 minus 3 squares, and so on. We have just taken 3 data points for now. And if we solve it, what we are going to get is the approximate value as 2.3. So what we can see? Now we will try to plot as well. Let us take this as our graph we are trying to plot. This is our x and y. So the point which were given, this is our 1, this is 2, this is correspondingly, this is 1, 2. Data set is 1, 1, 2, 2, 3, 3. So if we plot them, this is 1, 1, 2, 2, and 3, 3. In the first case, if you see here, the first case, h theta of x, it was just equal to x. And we got the distance as 0. So this will be the line, we know it will pass through the origin. And all the points will be lying on this line. Correct? This point will also be lying on this line. So this was our first case, h theta of x. Correct? Then we have taken theta 1 as 0.5 and we got 0.58. Obviously, in the initial case, we were having theta 1 as 1, theta 2 is 0.5. That means slope is decreasing. So this line will be somewhere here. So this is the line of the second case. This was the first case. And then we have taken slope as well. Slope is also equal to 0. Correct? So in that case, when the slope is 0, so that line will be going to be our x-axis only because the slope is 0. So this is the line. And in that case, we are getting larger distance as well. So we can see that this distance is larger as well between the predicted and the actual point. So from this, what we can predict that our line which we got in theta 1 equal to 1 case is the best fit line because the distance in that case is 0, which is minimum. Now, what we will do here, we will try to plot the graph between the value of theta 1 and the corresponding cost function. And let us take this value as 0.5, 1, 1.5. And here we will take the value as 0.5, 1, 1.5, 2, 2.5. So when we have taken theta 1 equal to 1, we got the point, the value as 0. For j equals to 0.5, that means in the second case, if we talk about, we got the output as 0.5. In the third case, when we have taken the value as equal to 0, theta 1 value we have taken as 0, what we are going to get? 2.34 something. So it will lie somewhere here. Similarly, if we keep on doing this iteration, changing different values of theta 1, and we try to plot them all and draw the graph, what we are going to get? We are going to get a nice parabolic curve. This will be the parabolic curve which we are going to. Obviously, there will be many iteration, many points we will get on this parabola in different iterations. And we also saw that in this case, our distance between the actual and the predicted point is the minimum. And this was the best fit line. So, and this we know is called as the global minimum. What does that mean? Wherever we are, suppose this is for certain value of theta 1, we are getting this line. Our ultimate aim should be such that to get a line which gives this value of j theta 1. That means our ultimate aim should be to reach to the global minimum. Along this parabolic curve, we'll try to slowly changing the value of theta 1 till we reach the global minimum. That is our aim. The parabolic curve which we are getting, that is called as the gradient descent. Gradient descent. Hope you understand the concept here. Thank you for watching. Let's meet in the next part of the video.